welcome to part 2 of review point 1, R.1. We're looking at the third objective, which is find the union and intersection of sets. Small mini typo right there, should be a D right there, and intersection of sets. Okay, so there are two different things when you're looking at sets. Remember, we were talking about sets like numbers, but there can be sets of lots of other different types of objects. So there are two concepts when we're talking about this. We have union and intersection. And these are two sort of different ways you can, I guess you could say, combine or look at how two sets interact, or what you take from the two sets. So first, let's look at union. The definition is the union of sets A and B. So the union of sets A and B, which is denoted just means how we write it, which is denoted A union B. Okay, so that symbol right there, I'm just going to take a moment and talk about this symbol. Union, it looks like a U. Okay, so just keep that in mind. U for union. All right. Okay, so that's how we denote it, A union B. What is this? Well, this is the set of elements that belong. That's supposed to be belong. Let's change that. Belong to set A or set B. Okay? So, for example, if you have, and normally we use a little sort of Venn diagram kind of looking at thing. If you had set A and set B, the union, it's talking about an item that belongs in either A or B. So it can be from either of them. Okay, so we would take everything. All right, the next one we have is the intersection of two sets A and B. So, the definition. The intersection of sets A and B denoted A, and this time it's an upside down U, A intersection B is the set of elements common to both A and B. Once again, I'll draw my little circles here. A and B. So this time, we're talking about what is the intersection of these two. So now intersection is different. Intersection is just what the two elements share in common. So right there, it would be this. That is the intersection. All right, so one way I like to remember these two is I think of the different types of relationships there are in life. Okay? So one main relationship would be a union or marriage, right? Marriage. Now what's another word for marriage, right? Marriage, another word is union. And when most people get married, when two people get married, you bring everything from one person's life and everything from the other person's life, and it is combined together. So everything from person A's life and everything from person B's life are combined together. You're not supposed to have any secrets, right? Hopefully. Okay, so that would be a marriage or a union. Okay? So a way to remember intersection would be it's a different relationship. This is a relationship of friends. Most of the time, you have a friend that shares a common interest with you. For example, I have friends at maybe where I play badminton, or I have friends where I go to the gym, or I have friends where I work at the college. So it differs. There are some things you share in common with that person, but you don't share everything in common with that person. So that's what an intersection is. It's just there's a certain stuff that you share in common. So that's how I'd remember intersection. Marriage, union, everything. Intersection, just what you share in common, but not everything. All right, let's work on an example. Given the following sets, A equal to the listed numbers, and B equal to the listed numbers, and C equal to the listed numbers. Find the following. Write the answer in interval notation and graph your answer as well. Those are actually the incorrect directions, so do me a favor. We're going to take these directions and get rid of them. The direction should actually be writing your answer in set notation, just like they are given here. Right answer in set notation. Alright, so the first one we're talking about is B. Now is that intersection or union? Well, it's downwards. Remember, U is for union, so that's going to be intersection. Intersection, remember, is just when they're friends. It's just what they have in common. So let's take a look at B and A, the ones we're focusing on here. Now we're looking for what they have in common. So let me write that down. What's in common? Okay, looking at their numbers, we have, let's see, a 0 in A and a 0 in B. Awesome, so they share that in common. Now A has a 2, but B does not. So we're not going to take that. A has a 3, but B does not. A has a 4. And B has a 4. A has a 5, B does not have a 5. A has a 6, B does not have a 6. Alright, so the numbers they share in common are 0 and 4. The next relationship we're looking at is B union C. So now when we're talking about union, remember union, think of the word for marriage, which is where you take everything. It's a joining of two entire lives, right? So B union C, we're just going to write everything down. And if there is a repeat, you're not going to repeat it when you write it down. Okay, see, B and C. Let's see, we're focusing on these two. B and C. So I'm going to go ahead and just start with the smallest number, which would be the -4. Remember, negative numbers, they're a little different than the positive numbers. The biggest negative number, let's see, if you have -14 and -1, remember, -14 would be smaller than -1. Okay, so -4. Then what else do we have? We have, start at 0, then go to 4, 0, 2, 2, 4, 6, and 8. And that looks like we have included all of them. So there we go, B union C. All right. Now let's take a look at the next ones. Go ahead, pause the video, try work on the next two by yourself, and check back in with me in a second. All right, so hopefully you've worked on these by yourself. So for C, it is A union C. So once again, we're thinking of a union or a marriage. So take every element. So for A and C, let's see, we have 0, 2, 3, 4, 5, 6, and 8. There we go. Every element is included. Now for last one, part D. We're looking at the intersection of C, so just what they have in common. Okay, so intersection of C, B and C. So we're looking at these two. What do they have in common? Well, -4 they don't have in common. 0 they don't have in common. They both share 4. And 8, they both share 8, but they don't share the 2 and the 6. So what they have in common is 4 and 8. All right, there we go. So that would be the union of two sets. And then I'm going to add one other problem here. Okay, so here we go. Given the two intervals, -2 to 5 and 0 to infinity, find the union and the intersection. Okay, so this time we're working with intervals on a graph versus the set notation we had up here. So I'm going to go ahead and write down my two separate graphs. for these two separate problems. So for this one, I'm going to go ahead and keep this as the intersection. And this one I'll use as the union. Okay, so what I'm going to do is first I'm going to graph each individual. And then we're going to go ahead and look at what the intersection and the union would be like. So for 2, 5, let's go ahead and graph 2, 5. So negative 2, I'll include 0, and then the 5. Alright, so negative 2 to 5. Well, those are both open-ended. So they're just going to be open circles. No fill-in. Okay, so we've graphed the first interval. Let's go ahead and graph the second interval, which is 0 to infinity, and we're including 0. I'll just go ahead and float this one up a little higher. And this one goes on to infinity. Okay, so now we're talking about the intersection of these two graphs. So remember, intersection, friendship, is just what they share in common. So looking at these two graphs, where are they overlapping? Well, they overlap right here. That's it, nowhere else. They don't overlap here, and they don't overlap here. Okay, so the interval where they overlap is going to be our answer, which is, oh, can we include 0? Yes, we can. They're both included there. So 0, 2. Ooh, and can we include 5? Well, 5 is included on the top one, but it's not included on the bottom one. So we can go up to 5, but we can't include it. And there we go, we have the intersection. Now let's take a look at the union. Once again, I'm going to go ahead and plot down my numbers. And I'll go ahead and graph my intervals. Pause the video and try to see if you can figure this one out by yourself. Check back in with me in a second. Okay, so hopefully you pause the video. We're talking about the union. So the union is whatever's in your life, whatever's in their life, you get married, everything is shared. Okay? So, even their family. Okay, so everything is shared, so that means everything. So the union, whatever we see first, negative 2, but we don't include it. We go up, and oh gosh, it doesn't stop. It just goes on till infinity. So there we have it. Negative 2, infinity is the union of these two intervals. Okay, so that was union. Let's look at the next objective, which is evaluate absolute value expressions. Alright, so we're given a definition of an absolute value. Alright, if we're letting x be a real number, okay, remember we've worked on real numbers, then the absolute value of x is, some fancy notation here, but we'll go over it. It's just going to be x, whatever's on the inside, if x is greater than 0. Another way of saying positive or 0. So greater than or equal to 0. But if the value on the inside is actually a negative value, then we have to take the opposite of it. Okay, so this is talking about a lot of times with math problems, if you're given something with an absolute value sign, most of us don't like working with it. So our goal is always to get rid of the absolute values. There are always two outcomes when you drop the absolute values. One outcome is it's going to be whatever was on the inside. The other outcome is it's going to be the opposite of what is on the inside. And how do we know if it's going to be this one or this one? Well, we just check on our restriction. Okay, so that's what we're going to be working on. Alright, so verbal interpretation. If the value inside x is a positive number, then when we drop the absolute values, it's just going to be whatever is on the inside. Okay, so for example, if I look at the absolute value of 2, what will I write if I drop the absolute value sign? Well, let's look at 2. 2 is already a positive number. It's already greater than or equal to 0. So what am I going to write down? Whatever's on the inside, 2. Okay. Now let's look at the other option. But if the inside value x is negative, then the absolute value of x, when we drop the absolute value signs, is the opposite of x. Let's take a look. Absolute value of 3. Well, when I look inside the absolute value symbols, what do I see? I see a negative 3. Well, negative 3 is less than 0, so what should I rewrite it as? The opposite of what's inside. Okay, well, I'm writing it as the opposite of what's inside. And what's inside? Negative 3. And then what's the opposite of negative 3? That's going to be positive 3. Alright, so as usual, I like to give fun ways to memorize this. One way I give to memorize this is, let's say you have kids, or maybe you know somebody who has children. What's something they always say when they leave the house? You better have a positive attitude when you leave the house, right? Alrighty, so imagine the absolute value symbols are your house. If the child's attitude is already positive, they can go outside exactly as they were before. But if your child had a negative attitude, then what do you need to do with that attitude in order to go outside? You have to change your attitude. Okay? So if you have a negative attitude, you got to change that attitude to go outside. Or to go to the mall, or whatever sort of outward incentive children have these days. Okay. Let's go ahead and use that. So, rewrite the following expressions without the absolute value bars. So as usual, if we're writing something without the absolute value bars, we have two options. We're going to check. What we want to know is, what is the inside value sign? So what is the sign of the inside value? Okay, if it's positive, remember, if the attitude's positive, then we don't need to change it. He's fine, go outside. If the attitude's negative, however, oops, I have those switched around. Let me change that. If the attitude is negative, then we have to change the attitude to let it outside. Okay, so that's what we're going to check for. What is the sign of the inside value? Well, the first one. Okay, so let's go ahead. Let's take a look at this child's attitude. Square root of 3 minus 3. Oh goodness, I don't know what the square root of 3 is. So this is a little kink in our plan here. I don't know what the sign of this is, because I don't know what the square root of 3 is. So let's go ahead. We're going to do some little maneuvering here. Square root of 3, what is that close to? Let's do an approximation. Well, the square root of 3, I know it's smaller than the square root of 4. But it's bigger than the square root of 2. Let me actually go ahead. Let me write this in a different color so you know it's scratch work. So I was saying the square root of 3 is smaller than the square root of 4. The square root of 3 is bigger than the square root of 2. So right now we're trying to estimate the square root of 3. All right. And that's also smaller than the square root of 1. Well, what's the square root of 1? The square root of 1 is just 1. So we know that the square root of 3 is bigger than that. What's the square root of 2? Well, the square root of 2 is 2. All right, so we figured something out here. Square root of 3 is in between 1 and 2. So that means the square root of 3 is smaller than 2. Okay, let me write that down. So square root of 3 is smaller than 2. So since this is smaller than 2, and we're subtracting 3 from it, the question is this going to be a positive or negative number? It's going to be negative because 3 is bigger than 2. Okay? 2 minus 3 is negative 1. Alrighty. So we know, because we did all that maneuvering, we had to do some estimation here, that this, square root of 3 minus 3, even though we don't know what number it is, this is going to be a negative number. And that's all we wanted to know. We didn't need to know the exact number it is, but we wanted to know what was the sign. Okay, so we know it's a negative number. Now what do we do with a negative attitude? What do we do with it? You got to change that attitude before you go outside. Alright, so to simplify our problem here, let's drop those parentheses, but when we drop the parentheses, because we know the attitude on the inside was negative, we have to take the opposite of our inside value. Okay, so then that's the negative root 3 plus 3. Not certain how I did that. I'll go ahead and show you. Using the distributive property, distribute over that negative, and we end up with negative root 3. And then negative times a negative is positive, so we end up with positive 3. And there is our answer. So again, what did we do? Check the sign on the inside. If it's positive, leave it be. If it's negative, you got to change the attitude. Or take the opposite of it, which is probably the more technical term. All right, so let's take a look at B. So, we have a variable in this one. So we're given this, and we're told that x is less than 2. We don't know what number it is exactly, but we do know that it's less than 2. So if it's less than 2, let's take a look at the inside, because remember, we're trying to find out what the sign is. This value is less than 2, and I'm subtracting 2 from it. So let's think of it this way. You have less than $2 in your wallet, but you go to 7-Eleven and you spend $2. Do you have enough money? No, you don't. You're in debt. That's negative. Okay, so we know this is going to be a negative number, which means we're going to have to change the attitude for it to come outside. So x minus 2, that's going to be, without the absolute value signs, the opposite of x minus 2. We can go ahead and do that distribution again to get rid of the parentheses, and we'll get negative x plus 2. And we're done. All right, let's take a look at the 5th objective. Use absolute value to represent distance. Okay, so another use for absolute value is just talking about the distance between two numbers, or the distance from one number on the number line to 0. For example, 0 to 8. That would be the distance. So, the distance between 2 points, A and B, on a number line is given by... Oh, and I realized an error on my part here. I got to take better care of my notes. Okay, it is given by A minus B, or absolute value of B minus A. Period. Capitalize. That is, comma, the distance between 2 points on a number line is the absolute value of their difference. Wow, a lot of typos here. Sorry about that. I'll do better care next time. Okay. Example 6. Find the distance between the following numbers. All right, so when we're trying to find the distance between two numbers, we're just going to take their difference, and that'll be the distance. So the difference between 5 and 8, the distance is going to be 5 minus 8. That's going to be negative 3. But remember, the inside's negative, so taking the absolute value, you take the negative, and you're left with 3. So this is telling me the distance between 5 and 8 is 3. Let's check this. Is this true? Let's go 5, 6, 7, 8 on a number line. Let's see. From 5, we go 1, 2, 3. Oh, look at that. It's right. The distance from 5 to 8 is 3. All right, we're good. Let's go ahead and check the next one. Pause the video, try it out by yourself, and check back in with me in a second. All right, so to find the distance, we take the difference. So 4 minus, this is where it gets tricky. It's 4 minus negative 1. So that's going to actually be 4. Okay, we have that double negative there. When you have the double negative, it becomes a positive. 4 plus 1, which is absolute value of 5. The inside value is positive already, so no need to change anything. And left with 5. Isn't that true? Let's go ahead and check on a number line. Negative 1, 0, 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5. It is true. The distance between negative 1 and 4 is 5. All right. There we go. We found the distance. Okay, so objective 6, applying the order of operations. Okay, so by definition, the definition of b to the n power. Well, for b to the n power, if b is a real number, so if b is an element of the real numbers, and n is an element of the natural numbers, okay, so that means not 0, then b to the n is just going to be b times b times b, however many times is told to you by this number. So n times. Okay. What does that mean? Well, here's an example. If I had 3 to the second power, that is saying I want the base 3 multiplied to itself 2 times. So that's going to be 3 times 3, which is 9. If I had 2 to the third power, that's 2 times 2 times 2, because we told 3 times. And that would equal 8. Alright, so we have that. Let's go ahead and take a look at PEMDAS. Hopefully this is something you've seen before. If not, we're going to go over it. So this is talking about the order of operations. When you see a bunch of addition, multiplication, division all in one problem, which one do you do first? Well, follow PEMDAS. Please excuse my dear Aunt Sally. P stands for parentheses or brackets. So the first thing you do, look inside those. Second thing you do, exponents. Okay, so hopefully this is review, so I'm going to go over this a little quicker. As usual, if you have any questions on any of these, feel free to shoot me an email. Then multiplication and division. This is where it gets a little weird. Multiplication and division, they are actually on equal terms. It's just whichever one comes first when you're reading left to right. Okay, and same goes for the next two. The next two stand for addition and subtraction. Okay, and as usual, which is first? Left to right. They are considered on the same level of importance. Now let's take a look at example 7. Simplify the following expressions. Okay, so using PEMDAS, first thing we're going to look at is P, which stands for parentheses. That means we are looking inside here. Can we do 6 minus 7? The answer is yes, we can. So I'll put my equal sign down, 5 plus 2, and then 6 minus 7 is going to be negative 1. And we bring down the square. Okay, so we've done the P. Next is exponents. Do we have any? The answer is yes, we do. Right here. Okay, so the negative 1 squared is going to be negative 1 times negative 1, which is 1. 5 plus 2 times 1. Next, after exponents, is multiplication or division. Well, I see a multiplication right here, 2 times 1. So that's the next thing we're going to do. So this is 5 plus 2 times 1 is 2. Okay, let's continue our work over here. And then 5 plus 2 is 7. And we are done. Alright, let's take a look at the next problem. I'm going to go ahead and write PEMDAS over here. Just to remind myself of the order of operations. These two are together and these two are together. So our first problem. Do I see any parentheses? No, I don't. So we're not looking at P anymore. How about exponents? Do I see any exponents? I do right here, the 2. So let's go ahead and get rid of that. And another thing to note, actually, which I did kind of forget. P, you also include square roots. Let me go ahead and change that a little bit. Square root is a grouping symbol. Okay, so we actually do see that right here. So let's go ahead and work on those two. So that's going to be 2 squared, which is 4, plus, and the square root of 2. Square root of 2 is I'm sorry, I said the answer. Square root of 4 is 2. All right. So next. Well, on the top we have 4 plus 2. What you can do is 6. And on the bottom we have 10. All right, you might be tempted to leave your answer as 6 over 10, but in math, everything must be simplified. We like to simplify life. So we need to see, can we simplify this? 6 and 10. Is there a number that can divide into 6 and 10? The answer is yes, that number is 2. We can take a 2 out of the top and the bottom. 6 divided by 2 is 3. And 10 divided by 2 is 5. And we are done. All right. Let's take a look at the next part, part C. Oh, a lot of stuff here. Go ahead, pause the video, try work on this by yourself using PEMDAS, and check back in with me in a second. Alright, so using PEMDAS, as usual, we're going to go for P, which is the parentheses. Looking for the innermost parentheses, right here. And we're looking for the square root of 64. So the square root of 64 is 8. Alright, let's go ahead and simplify that. So this is 7 minus little squiggle plus 5 plus 4 times 2 minus 5 minus, and the square root of 64 we simplified to 8 squared bracket squiggle. Whew, okay. Still we're looking inside those parentheses. 5 minus 8, we can do that. That is going to be, let me just write everything down first. 5 minus 8 is negative 3, and we are bringing down that 2 for squaring. Alright, so next thing, we've got to do exponent. So that's going to be 3 squared. So negative 3 squared is negative 3 times negative 3, which is going to be negative times negative is positive. 3 times 3 is 9. 9. So this is 7 minus squiggle 5 plus 4 times 2 minus 9 squiggle. Whew, alright, well, I'm making it through. Next we have 2 minus 9. We can do that. That's going to be negative 7. So 5 plus 4 times negative 7. Ugh, the hand is getting weak. Okay. Alright, now we have the 4 times the negative 7. 4 times negative 7? Negative 28. So you could do 5 plus negative 28, or you could just do 5 minus 28. Both would work. Both will come out with the same thing, so they're both okay. So we have 5 minus 28. 5 minus 28 is going to be negative 23. Okay, let's go ahead and continue. Ooh, up here. Nice arrow to indicate where you're going. Notice the equal signs are nice and lined up here to let the instructor or whoever's reading your math work know what you're doing. So then we have 7. Ooh, it's a double negative. Okay, you might be concerned. What are these squiggly signs? But remember, those squigglies are just another form of the parentheses we use, which would be the exact same way as writing 7 minus negative 23. We have those double parentheses hanging out once again. And we're left with 7 plus 23, which is going to be 30. And our answer is 30. Whew! A lot of work, but we got it done. Alright. We're going to pause here, and then the next video, part 3, we'll go over objectives 7 and objective 8, and that'll be it for review point 1.